Dear students, in this video we are going to look into control chart for attributes. Attributes can be classified like defective or non-defective, a good article or a bad one, yes of a product or no of a product, acceptable or unacceptable. Measurement is typically counting defectives. So we would like to just count the defective in the sample count and try to put that in the chart. So the chart may measure in two different forms. One is percent defective P chart and another one is number of a defect C chart. So in this presentation we are going to look into P chart and NP chart. Both comes under percent defective. Out of some certain number of products, how many are defective? So with that we just move to the chart. So if a P is not known, P means a proportion, then the unbiased estimator for P can be calculated like a P bar, which is given as a D1 plus etc. Dn divided by N1 plus etc. Nm, where D1, D2 represents the number of a defective in the ith sample. So for P chart, the central line is given as P bar and upper control limit is given by P bar plus 3 times the square root of P bar into 1 minus P bar divided by N. For lower control limit, it is P bar minus 3 times square root of P bar into 1 minus P bar divided by N. For P chart, if a P is known, then the central line is given as P and upper control limit is P plus 3 times root of P into 1 minus P by N, and the lower control limit is P minus 3 times square root of P into 1 minus P by N. Now for the NP chart, the expressions are simple. What we have for this P chart multiply by 3 will get automatically NP chart. So the central line is given by N times P bar. Upper control limit is given by N times P bar plus 3 times square root of P bar into 1 minus P bar by N. And lower control limit is equal to N times P bar minus 3 times square root of P bar into 1 minus P bar by N. So some of the patterns that can be observed in the control chart. This looks in the form of normal, so we can call the process is in control. We have ups and downs which are equally distributed. So in this graph, there is a point which goes out of the control limit, above the upper control limit. So we can call this process as out of control. If the trends are in one direction with 5 plots, either in increasing or in decreasing form, then investigation should be carried over to check the progressive change. Here we have 2 points which are very close to the lower limit. So in this case too, the process should be investigated for the causes. We have 5 points above the central line which need to be investigated further. So this is a erratic behavior of the process. So natural variation, if it occurs in a small form, then that could meet the standard requirements, whatever that has been produced. A process in a statistical control does not necessarily meet the design specification. So process capability is a measure of the relationship between the natural variation of the process and the design specifications. Thank you.